Hello students. So in this lecture series we will be starting previous year gate questions of network theory, and the topic of this lecture is transient analysis. There will be many subparts of this lecture and we will be covering all the previous year of electronics and electrical of transient analysis in this video series. There will be other video series completing the whole network theory and other subjects of GATE, completing all the previous year questions. So in this lecture series I will be starting with transient analysis, and in this part, this is part 1 of this lecture series, and in this part I will be covering from 2019 GATE questions to 2016 GATE questions. Okay, in this part. In the later parts we will be covering the other previous year questions. Okay, so let's start with this question. This is question number 1. This is question number 1 and this was asked in 2019 electronics EC. Okay, so first of all let's look at what all is given in the question. So it is given that there's a RC circuit and which has a variable resistance, that is RT. So this is a variable resistance and the value of resistance is given by 1 minus small t divided by capital T, where small t varies from 0 to capital T. Okay, and R0 is also given to us, that is 1 ohm, and capacitance value is given to us 1 farad. It is also given that at t equal to 3 R0 C, the value of capital T is also given, that 3 R0 C, and we can see that R0 is 1 ohm and C is 1 farad, so capital T is equal to 3. Okay, and source voltage is 1 volt. This all is given to us. Now if the current at t equals to 0 is 1 ampere, then the current IT in amperes at time t equals to capital T by 2. So it is given that at t equal to 0 the current is 1 ampere and we have to find the current at t equals to T by 2, that is at t equals to 1.5, right? So first of all, if we modify RT equation, so it is equals to 1 minus P by 3. Okay, now very simple question, it is a very simple question, very basic question. Now we know that for t less than 0 the switch was open. So there is a 1 volt battery, there is a resistance R and the capacitance C, and the switch is open. Now since the switch is open, we can say that capacitance was discharged. Capacitor was discharged initially. Okay, so initial voltage across capacitance is 0 volts. Okay, there is no initial charge on the capacitance. Now for t greater than 0 the circuit is a 1 volt battery, resistance R and C. IT is also the current, 1 volt battery. Now if we write the KVL of this equation of this loop, then it is very simple, and we can say that if I write KVL in this loop, so for example this is point A, this is B, this is C, so the loop is A B C A. So A to B it is minus 1, B to C it is IT into R, C to A it is voltage across capacitance, okay, VCT, that is equals to 0. Okay, now when we know that voltage across capacitance is 1 upon C integral of the current, so it is minus 1 plus IT into R. What is the value of R? 1 minus T by 3 plus VCT, where VCT is 1 upon C integral IT dt, that is 0. Now okay, so now we have IT minus T by 3 IT plus 1 upon C integral IT is equal to 1. Now this is the equation. Now if we differentiate both sides, then we will get dit by dt minus T by 3 dit by dt minus IT by 3 plus IT by C is equal to 0. Or I can say that dit over dt, with value of C is equal to 1, right? So dit by dt 1 minus T by 3 is equal to IT upon 3 minus IT. So I have to add a page here. Okay. Now from this equation we can see that dit over dt is equal to minus 2 by 3 IT divided by 1 minus T by 3. Okay. Or we can solve it, then we get 2 times IT by 3 minus T dit by dt. Okay, so from here we can see that dit by IT is equals to minus 2 by 3 minus T dt. So we can see that this integration we can see that this integration will give us a log equation, where if we integrate both sides then we will get ln of it. Okay, because if we integrate this we will get ln of it, that is equal to 2 times of ln of 3 minus t plus ln of VSC is a constant. Okay, now from here we can see that it is equal to c times of 3 minus t whole square. Okay, for t greater than 0. Now we can easily see that since it is given that I0, that is t equals to 0, is equal to 1 ampere, so from here we can see that value of C will be 1 upon 9. So IT will be 1 upon 9 3 minus t whole square, and at t equal to t by 2, that is 1.5, we can easily see that IT value will be 1 upon 9 3 minus 1.5 whole square, that is 0.25 amperes. So this is the answer, that is 0.25 amperes. Okay, so a little maths is involved in this question, but rather otherwise it's a very simple question. Okay, now this is question number 2. This is GATE 2018 EC question. Okay, now it is given that For the circuit given in the figure, the magnitude of loop current we have to find at 0.5 seconds after closing the switch. Okay, so this switch was initially open. So if we say that the switch closes at t equals to 0, let us assume that the switch closes at t equals to 0. So for t less than 0, the circuit will be drawn like this, as I am drawing it. Okay, so in this circuit we can see that no current will flow. Okay, current is 0. So this inductor is initially discharged, no charge on this inductor. Okay, so this inductor is initially discharged. Now for t greater than 0, the switch will be connected. Okay, so we have to find the current, okay, the loop current, and the current will flow in this direction at t equals to 0.5. Okay, now very simple question, it's a simple RL circuit, where equivalent resistance is 2 ohms because 1 and 1 ohms are in series, and L is equals to 1 Henry. Okay, so we know the equation of IT, that is equal to, okay, that is equal to I infinity minus I0 e to power minus t r by L. Okay, so this is the equation. Now if you look at this circuit for t greater than 0, we know that at t equals to 0 plus and at t equals to 0 minus, the inductor current does not changes, and we know that at t equals to 0 minus there was no current through the inductor. So at t equals to 0 plus also, this inductor will act as a current source, or I can say that since this inductor was uncharged, so it will act as a current source of 0 amperes at t equals to 0 plus. So no current will flow in this loop, 0 ampere current will flow in this loop. So IT at t equals to 0 plus, or I can say I0 is equals to 0 amperes. At t equals to infinity, when the whole inductor gets charged, so at t equals to infinity, inductor will be replaced by a short circuit. Here it is 1 ohms. Okay, so inductor is replaced by a short circuit, 1 volt battery, and inductor replaced by a short circuit, 1 volt battery, 2 ohm resistance. So at we can say that I infinity equals to 0.5 amperes. So this is equation number 1, this is equation number 2, this is equation number 3. So we can say that IT is equals to 0.5 minus 0.5 e to power minus t r by L, where it is r by L is 2. We have already seen that. So R and L, R is 2 ohms, L is 1 Henry. So it is 0.51 minus e to power minus 2t. Now at t equals to 0.5 seconds, I 0.5 is equals to 0.51 minus E inverse. So that is equal to 0.316 amperes.